Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge, third question, and its difficulty level is medium. So in this question, let me give you the overview for this question. So in this question we are given with intervals, and these intervals we are required to club them in subgroups, and each group should have those intervals only which do not intersect with each other. So this is overview. Let us first take for the constraints and then we will go ahead with the question reading. So constraints are given order of 10 raised to power 5. Means length of that is 10 raised to power 5, so we can't use n square solution here. We would be required to either use n or n log n. Interval length is basically 2. That should be 2 only. Intervals of I, that is the vector which is being given inside that what we say as a wrapper vector. So that should be 2 only. One would be start and other would be end, so that's why. And the left and right, this is basically 10 raised to power 10 raised to power 5. Right. Okay. Basically, the means in this intervals I, we are given with 2 elements, right? And those 2 elements will be from 1 to 10 raised to power 6 only. That's they want to say. So now let us read this question. So here you are given with 2D integer arrays intervals where intervals of I equals to left of I, right of I represent inclusive interval left of I, right of I. That simply means that in that interval left of I, right of I which is being given to us. Why this is not working? 1 minute. Yeah. So left of I and right of I which is being given to us, that is, this is the left of I and this is the right of I, right? So this I is basically, here each element simply refers to the I's index, means this one, this one, this one, this one, this one. These are basically representing the index or the my outer vector. So that's the thing here. So that is why we are saying it as left of I and right of I. Now comes the next part, that they were saying that this could be till 10 raised to power 6 and this could be minimum 1, means equal to is also there. So that's the thing which they were saying. So, and these left of I and right of I are inclusive in nature, means in that interval both of them would be included also. So this was about this. And now comes the next part, that you have to divide the intervals into one or more groups such that each interval is exactly one group and no two intervals that are in the same group intersect with each other. So like in this you can see that 1, 5, 6, 8, no one is intersecting each other. This is also unique, this is also unique. So in this also this is unique, but this is also unique and this is also unique, and you can see that 1, 5, one interval which is being there, means 1 start here, 5 start here, then 6 would be here and then 8 would be here, right? So this is one interval, this is one interval, that is they are not intersecting. Then in the other one you can see that 2 starts here, 3 here, 5 here, 10 here, right? So here you can simply take that in these intervals 2 and 3 which are being there, so both of them again don't intersect. And at the end 1 and 10 which is being there, so this comes out to be some other interval, which, because you can see that if we take 1 and 10 here, so it will intersect all of this, right? And here also it will intersect all of this, right? So that's why we have taken this at the another interval, that is a third interval. So yeah, this was all for this particular explanation. Now comes the next part about this next, how we are required to check for the same. So here we are having 1 and 3, right? So here you can check that 1 and 3 is there, then 5 and 6 is being there, right? Then if we go ahead, then 8 and 10 is there, then if we go ahead, then 11, let me take this other way. Then here you can check that 11 and then 11 and here 13 is there, right? 1, 3, 5, 6, 8, 10, 11, 13. No one of them is overlapping with each other, right? So that's why we can take this as completely as one group. And that's why our answer is basically 1. So this was explanation about this question with the constraints and so on. Now comes the part that how we are required to code this question. So basically, for checking that if intervals are overlapping or not, what we are required to do at the first is that we are required to check for the first element itself. Means we will sort them, right? So that every interval which comes up come as sorted by the starting of those particular elements. Basically, what I'm saying is that 5 is there, 6 is there, 1 is there, 2 is there, and 1 is there, right? So basically, we require these intervals in this form, 1, 10, so that we could compare with each other. 2, 3, and 1 minute. So this is like this. We want 1, 10 means when it becomes something like this. In this, you can see that 1 and 5 is also there, right? So that's why. So we will take that 1 and 5. Which one is the smaller as per the second element? So that would be this one, right? So we will get the sorting in this manner. Now 5 and 6 both are unique only. So 5 and 10 would be there, and 6 and 8 would be there. So now we got the sorting as per the first element. If first element is already equal, then we will check as per the second element. Means basically sorting for as per the first element, and then we will be checking for the second element. Then according to that only we'll sort. That this condition comes up if both first are equal. So this is the criteria for a sorting purpose. So why we are sorting? Now that is the question. We are sorting so that we can check. See, if they are already sorted, then it becomes easy for us to represent them on the number line, right? You can easily take that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now you can easily take on number lines that which intervals are overlapping and which are not. If we start from 1, then one interval is 1 to 5 and the other interval which is being there, that is 1 to 10. Now it becomes easy only, right? That there are two intervals which are starting, basically two intervals which are being starting from this one, and one is 1 to 5 and other is 1 to 10. So that makes the sense to basically group these elements separately. So from this point only we got two groups. So this is the thing. That's why we are sorting. And now comes the part for 2 and 3, 5 and 10. So now we are required to check that because then we will be having something like that it is maintaining itself in such a manner that it sort again and again itself with the smallest element first and the largest element second. So then we will be easily able to compare that what is there at the first, means which is the smallest one, and that we will be checking by this element. Means when it is already sorted, right? So we can easily check by the ending interval. If that ending interval basically lies inside the first group, right? If it lies inside the first group, then we are required to group it separately. That makes the another group. So this group would be grouped separately. So basically now we are having three groups till now. This is one group which we are having, and this is third group which we are having. So till now we got the three groups. That is the thing. You can easily see that there are three groups, and that we got. First thing was because the first was equal, right? And second we got because it lies in the first intervals itself, right? So that's why we got three groups till now. Now let us check that if we got any other similar group or not. So now we check for 5 and 10. So the thing is that at the top we will be having this 1 to 5 only, right? Because our intervals are like in this manner, means being sorted in this manner. Now comes the part for the 5 and 10. Now you can check that at top this element would be there, means this interval will be there. And now we will be checking that do we got anything which gets into overlapping sense of this. If it is there, yeah, it is there. Because 5 is basically overlapping with the first itself. Because you can see that this 5 comes in that interval only. Right? This one and this. Both of them are intersecting. And because of this thing only, for this 5, 8, we are required to check for other group. So we will be directly deleting this particular group out of our group, and we will be then checking for the other group which is being there. And then we check for this 1 and 10. Then this 1 and 10 is again overlapping with the same. Then we will check for this 2 and 3. Then we got to know that 2 and 3 is that one which is not basically overlapping with the same. So that's why this comes out to be another group into this 2 and 3. Now we will be checking for the 6 and 8. So for 6 and 8, now we are required to check that which one is there which is not overlapping with the same. So when we check for the same, then in that criteria we check for this one and we got that yes, this is that group which is not overlapping. So that's why now this 6 and 8 is basically added to the group of this particular 1 and 5 only. So in that context now we got 3 groups, and that is the thing which we are required to do in our question. Now the thing is that presently as per the intuition now it is becoming like that it is much more in the sense of means it is much more complex sort of, right? But in reality it is not much complex. If we use a data structure in such a manner, in such efficient manner, so it will sort by itself, and even it will make us easily accessible that particular group which we are required with. So there only comes the part that how we are required to modify our algorithm for the same. So for that criteria, what we will be doing is, we will choose a data structure in such a manner that it sorts by itself and makes us easily accessible for a topmost element. And for that purpose, in C++ we are having heap. Basically not in C++ but in all languages, but in C++ we are having the max heap. But as we require the smallest element at the top, so that's why we will be making our max heap into min heap. And after making our heap in the manner of min heap, then we will be easily able to get our answer in such a manner that whatsoever interval is the smallest interval, means ending part of that interval is basically the smallest one, that would be at the top. So the thing is that when we got to this, let me choose another color. So when we will be at this 1 5 and this 1 10, right? So when we will be storing this 5 and 10, so this 5 would be at the top and then 10 would be there. Then we get to know about this 2 and 3. Then 3 is basically smaller than this particular interval, that is 5, right? So that's why this would be added as a new group. So now we are having 5, 10 and basically this basically we are having in this sense, 1 minute, means we are having 3, 5 and 10 in our min heap. Now after that when we check for this particular interval, so we will be checking that is there anything, means this 10 which is being there, now we will be checking that if this 10 is basically greater than our topmost element or not. Yes, it is greater than our topmost element. So if it is greater than our topmost element, then it surely means that it will not merge into this particular interval, right? So that's why we won't be adding up this to as it is not merging, right? So we can easily add up this toward this particular element, right? So in that context we won't be adding this particular into our min heap, and this we will be going ahead with this particular. And here you can check that this 8. So this 8 is again greater than this particular 3, right? So that's why again we won't be adding this particular 8 to our min heap. And at the end we will be getting these 3 groups as our answer. And we were only required with this only. So this was for this particular and dry run for this particular first example. In the second interval, the thing would be that when we would be having 3, 6, 10 and 11, the thing would be that before pushing them to our heap, we will be at that moment only first check as per the first element itself, and then only we will be able to push that into our heap. So this was a dry run sort of for the first example and somehow the intuition about this question. Now let me show you the code for this particular question, and after that we'll discuss about the time complexity. So this was all. Now let us go through the code. So first thing is that first we are sorting all the intervals so that we get all intervals in that sorted manner, the way I was showing you the time. And then we are making our min heap, because in C++ we are having max heap. So for making the min heap, we require to add this greater int to our min heap, and as it will be internally storing the vector of int only. So that's why we are describing it by this, and each vector of int would be having the integer data type. So that's why it is like this. Now comes the part that first thing is that we will be pushing our first interval itself into our heap. So here we are taking the first row and the second column. Means basically when we are having 1 and 2, so this particular 2 would be pushed into our heap. Because what we are doing is we are pushing all the ending elements into our heap. And now, at the starting only we'll keep our answer as 1, just because of this fact that at the worst case scenario, when we are having all the elements unique, means all the intervals are basically unique, then in that criteria, what we are doing is then we are required to return answer as 1 itself. So now comes the next part. There we are starting from 1 because we have already pushed one element, right? So that's why now we will be traversing this particular which is being given to us, and that's what we are doing. Now in this we are checking as per the interval which is next and its first element. So basically when we had already sorted that, so we were having 110 and 15, right, in our sorted timeline. So that was the thing which we were having. Basically the correct manner of writing this is something like this. Let me write it. So the thing is that it is an 1, right? So at 1 we would be having 15 and 110. That would be the thing. So here we will be checking for 110 only, but here first we are checking as per the 1. So if both of them are equal, because they are equal, right? So we will be directly pushing this 10 also, and this 5 would also be there. So now in our heap we are having 5 and then 10, because it is in the sense of top manner. So let us take it in that sense only, the way it is. So 5 is there at the top and then 10 is there. So this is what our heap is containing at present moment. So this was for 110 and 15. Now in else criteria it won't be going. Now let us check for the what is the next element. I guess it was 2, 3. So as it is sorted only, so here it will come up with the 2, 3. Now here again it will check for the first element, that is 2, and you can check that 2 is basically less than our heap top. Not less than but greater than our heap top, right? Because our heap what I am saying, this particular we would be having this 2, right? Yes, it will be there, and our heap top would be having the element 5 because we are storing with that. So that's why now when 2 is basically less than our 5, right? So that's why we will be now pushing at this particular 3 into this, and as it is a min heap, so it will organize itself in this manner. Means 3 is now this and then 5 is being there. So like this manner, now our heap is having 3 elements. Now the next element, I guess it was, not I guess, we should check. So the next element, now we were having 1, 5 was there, 1, 10 is there, then 2, 3 is there, then 5, 10 and 6, 8. Okay. 5, 10 and 6, 8 are the next intervals. So next one is 5 and then 6. So here we were having 5, 10 and 6, 8. So now next we will be checking for interval of I 0. So now we are at this 5, 10. So we can check that 5 is basically, since I of 0, so 5 is basically greater than our heap dot top, right? Because at our start we are having this 3. Let me write this 3 and 5 is there. So we are having 3 and 5, right? And we can check in this 5, 10 at the top I 0. So here we are having this 5 and at heap top we are having 3. So this condition is not satisfied. So that's why we will be popping out from the heap and we will be pushing our new interval. That is at 5, 10 would be pushed, and that context we will be having one more 10 right? And 3 would be popped out. So now our answer would be something like this: 3, 5 and 10. So our answer would be something like this, means 5 and 10. So now we would be having elements like this. And then comes the next part for the 6 and 8. So now you can check that again the 6 and 8 which is being there. So here I0, that is the first element, that is our 6, and that particular is basically greater than, right? So its next element that would be pushed. But again the thing was that 10 is basically occurring 2 times, right? And then 8 comes out into the same. So in that context we will be having 5, 8 and then 10. And at the end when we will be returning our size, so we will be getting 3 as our answer. So this was all about this particular question. Yeah, so as for the time complexity and the space complexity, as we are here sorting, so it will be log n and simply refers to the number of elements which are being there present in our intervals, vector or vector. And then in a priority queue again it will be log n, and then this particular n, this will be n log n, because after sorting we are again rearranging them only, right? So in overall context, the time complexity would be order of log n, and the space complexity will be simply order of n because of the number of elements the way we are taking. So that's why this is the whole about this particular question. Yeah. And one more thing, as Newton School is starting with some coding competition which will be starting soon in the September itself. So you could figure out with that link in the description below, and you can find every details about the same in that link. And the thing is that you would be doing this Leetcode daily challenges, Leetcode weekly challenges, bi-weekly, and then also doing the Newton School coding contest. So it will become much more beneficial for you for your practice. So that would be the good thing for you, and increasing your speed and so on. So yeah, this was all for this particular question. I hope you liked the video. So please do like and subscribe to the channel, and do share among your friends. So yeah, this was all. Thank you.